Hi everybody, hope you're doing well. Okay, so this is today's lesson. I actually switched the order a little bit. So this analyzing functions lesson is actually number 89. So you'll be doing homework number 89 tonight instead of 88. Remember, the homework is on my website, as are all these blanks. So you can follow along, take your own notes. And the homework now has to be posted on Google Classroom. So I'll make that assignment when I'm done with this. But okay, so you're going to be learning via video an 11th grade lesson, but you guys can do this. You guys are awesome. It's all about the vocab and symbols and stuff like that, but I know you guys got this. If you have any questions, feel free to email me, but here we go. Okay, so we start off with something similar you had on your homework last night, so this should not be too bad. This is from our piecewise units. So remember, this is your x value, and on a graph, you don't really show any work. You just go to where x is -3, and you find the function either below or above, which in this case it's above, and you want the corresponding y value, so that is 3. So this is going to be your y value. So the next one, go to where x is 1, find the graph, what's the corresponding y value, and that is -9. And then our last one, go to where x is 2, find the corresponding y value, and that is -8. Okay, that wasn't that bad. Next part, domain. So this, again, you have already learned, because some of this you will learn. Domain are your x values. So domain, and this is why I kind of want to switch the order, kind of went more with what we've been doing. So domain is along this axis here. Okay, so along this axis. So it's only from right here to right here, and that is it. So it's only from -7 to +5. Okay, -7 to +5. And notice when they give you a function, they're going to give you something you haven't really seen. We haven't seen a graph like this. All right, so to write this, we're going to do our set builder. From -7, that was our open circle. And then the 5 was the closed circle. So that's why you have those symbols. And then I'm also going to write it with interval notation because, again, I have no clue what the region is going to ask us to do. So we always want to prepare for everything. Okay, so now you want to do your range. Range are your y values. Remember, that's going up and down. Okay, your range are your up and down. And you always want to be numerical order. So you want to go from your lowest, which is -9. And then you keep going, keep going, keep going. And this is where I stop. So from -9 to 7. And don't forget, when you do that set builder, make sure you put it as y. Okay, so that's your set builder. And then this would be your interval notation. Notice I'm putting this as a filled in circle because as this continues, okay, it's a solid line. So we assume that is filled in. So that is going to be with your brace. All right, next vocabulary word, zero. So we've done this a ton. Remember, zeros are also your x-intercepts. And they're also your roots. And then this is when y equals 0. That's important. When y equals 0, or where the function crosses the x-axis. So we do this a lot when we're doing like those work backwards questions where you have to look for the roots and then work backwards to get the quadratic. So that's why you basically know these. So anywhere along here you see something intersect the x-axis. You have -6, -2, and 4. Okay, -6, -2, and 4. So I'm going to write that a couple different ways. So that's in like roster form, basically. And then I'll write our list. Y-intercept. This is where the function crosses the y-axis, and this is when x equals 0 this time. Okay, so instead of when y equaling 0, where x is 0. So where does this curved graph cross over the y-axis? At this dot right here. And again, you want to tell them the y value. So that's -8. Okay, notice these are the braces. All right, so those are the first couple. Now we're going to move on to our new vocabulary. Okay, and I'm going to keep referring back to this right here. All right, new vocab. Here we go. So the first new vocab is called increasing. Okay, I'm going to try to use my highlighters too to try to help you out. You know, I'm all about the highlighters. So this is where y1 is less than y2. And for increasing, it's very important that you describe in terms of x. And this is how it gets a little tricky. Okay, so for the increasing, I like to think of up the roller coaster. Okay, so going up the roller coaster. So on this graph, okay, you want to see the section where it's going up the roller coaster. Okay, at this point, you'd go down. So I don't want to do anything here. And then from right here, going up the roller coaster, up the roller coaster, up the roller coaster. Okay, so where did this part start for the x? That started at -7. And then this part went to what? It went to -4. And then this was from 1 to 5. Notice I'm looking at all the x values. That's how I'm describing it. Okay, so there's 3 different ways that I have to teach you how to write this, because one way is not good enough. So the first way is in words. So between x equals -7 and x equals -4, or, so remember this is how you did kind of like your discontinuity range and domain the other day. Between x equals 1 and x equals 5. So -7 to -4, 1 to 5. Okay, the second way is our interval notation. Okay, remember or, that's your u. And then I want to go over why these are parentheses. Because not actually increasing at those values. So right here, when you start, think of like start. You get in that roller coaster, you're sitting there, you're waiting to go up this really scary, steep hill. At this point, are you increasing? No, because you're stopped there. And then you get up to this point, and this is kind of where like the direction changes from going up the hill to down the hill. So at this point, you're changing direction. You're not specifically actually increasing at that point. So because of that, we use parentheses. So that's a little tricky. Okay, and then the third way is our set builder. Remember, set builder has to have the word or, it cannot have the u. That's way back from our interval notation unit, or our set builder unit. And set theory, okay. So now we're going to go decreasing. And this is going to be down the roller coaster. And this is where y1 is greater than y2. And again, describe in terms of x. All right, so now we're going to go down the roller coaster. So I'm going to go down the roller coaster from -4, down the roller coaster to 1. Do I have any other going down the roller coaster? No. So I am done. So we want to write this now. So again, down the roller coaster, that's from -4 to 1. Remember, at those specific points, you're not actually decreasing. This is kind of your change of motion, and this is your change from decreasing to increase. So at those specific points, we're going to use parentheses because it doesn't actually equal at that point. All right, so our 3 types again. So in words, between x equals -4 and x equals 1, okay? Or we can write it this way. Okay, and again, I'm going to write parentheses because you're not actually decreasing at those values. And then our set builder between negative 4 and 1. And again, notice there's no lines underneath because it's not actually equal to. All right, so those are 2 new words. Increasing up the roller coaster, think of almost like a positive slope. Decreasing down the roller coaster, think of like a negative slope, but it's going to be more in terms of a curve. All right, next, positive. F of x is greater than 0. Remember, f of x is the same thing as y. So you're talking about where y is greater than 0, where y is greater than 0. So the best way to help you out with this, it's where the function is above the x-axis. The function is above the x-axis. So we're talking about only the first and second quadrants. Okay, we're talking about only the first and second quadrant. And again, like the 2 above, we're going to describe in terms of x. We're going to describe in terms of x. So again, you're looking for anything that is above the y-axis, or the x-axis, okay? So it doesn't matter if it's increasing or decreasing, it has to be above. So from -6, above, to 2. This whole entire curve part is above the x-axis. Okay, this is below, and then this section right here is above. Okay, so we have 2 sections that are above, so we have to account for both of them. Okay, so again, it's above the x-axis. All right, here we go. 3 ways. So it's going to be in words. So between x equals -6 and x equals -2. So again, this has to be an end. Or, now here's that second part. Okay, so when you're describing this section, use the word end, like I did above. But then when you're jumping to the next section, you're going to use the word or. Okay, so or between x equals 4 and x equals 5. Okay, again, it's everything that's above in quadrant 1 and 2. Okay, so we're going to go -6 to -2, u 4, 5. Okay, so this right here, okay, if you notice, these are parentheses, and that's because it's equal to 0. Okay, so this is equal to 0, this is equal to 0, and this is equal to 0. Okay, but now this one has a bracket, okay, because it's greater than 0. Okay, so here I'm going to write, maybe this will help, not actually positive. So remember, let's go over this again. Okay, so positive means it's greater than 0, where y is greater than 0. But at this dot right here, y is equal to 0. This dot right here, -2, 0, y is equal to 0. So technically, remember, 0 is not positive. Okay, so it's not actually positive because those 3, okay, 1, 2, and this third one, 4, 3, those are not actually positive. Okay, because they're equal to 0. Now here, your y value is 7. Well, is 7 bigger than 0? Well, yes, it is. Because 7 is bigger than 0, okay, which is your y value. You're going to have the 5 with the brace. So now, why did I just say 7 and now I'm saying 5? Remember, you're going to describe with the x. So for this coordinate, I'm describing it with the x. Okay, but I'm looking at the y. I'm looking at the y. Okay, so all 3 of these dots, all 3 of these x values had y's that were equal to 0. 0 is not positive, so it's almost like a not inclusive. So that's why you have the parentheses. But this last dot, because it is above 0, because 7 is technically, it's really a positive value, that's why this one has your bracket. So remember, this is including the 5. Including the 5. All right, and last one. Again, we're describing it in terms of x. So it is between the x values of -6 and 2, or between -4 and 5, but the 5 has to be including. Okay, so one more time. This has this value of 7, y value of 7 is greater than 0. So because it's greater than 0, the corresponding x value gets the brace. Where these three, the y values are 0. 0 is not positive. Okay, it's neutral. So those ones are going to get the parentheses. So that was kind of confusing, huh? Just try your best. All right, so now we're going to go negative. Okay, so again, f of x means really y. So it's just the opposite of this. So now we're going to go where y is less than 0. And you want the function where the function is below the x-axis. So now we're talking about quadrants 3 and quadrants 4. And again, you want to describe in terms of x. So you're looking at the y's, but you're using those x values to give me these three. All right, so let's look at our graph. So where are we below this x-axis? Okay, where are my y values negative? So that would be from here to here. And that would be from here to here. Okay, so notice here, the positive 4 has a corresponding y of 0. So that's going to be a parentheses. Y is not negative. Negative 2 has a corresponding of y. Y is not negative. That's going to be parentheses. 6, corresponding y value is 0. 0 is not negative, so that's going to be parentheses. All right, and then we have this dot. So I have a -7, and I have a corresponding of -5. Well, yeah, -5, that's definitely negative. So can't we include that? Shouldn't that be a bracket? Well, unfortunately, it's not because we have an open circle. So this one over here, you did put a bracket because 7 is positive and because it's filled in. But now here, hopefully you can see it, I didn't go over it too much, that is an open circle. So what would have been your bracket, because the corresponding y value is actually a negative number, this time it's open because it's not filled in. It's an open circle, which means not inclusive. So let's write that down. So between x equals -7, there's the end, x equals -6, or because you have to write the separate sections, between x equals -2 and x equals 4. So between -7 and -6, and then between -2 and +4. So we have our interval notation with our u and not the or. And because open circle for the -7, okay, so that's why it's not a brace, it's open circle. And then this one, and this one. The reason it's parentheses, I actually put it to here. Sorry, not there, because it's equal to 0 and not actually negative. Okay, so if it's not actually negative, if the y, and by it, I mean the y value, if the y value is not actually negative and 0 is not negative or positive, it has to be parentheses. Okay, this was a brace because of the filled in circle. This normally would have been a brace, but it is an open circle. Okay. Or -2 is less than x, which is less than 4. Okay, all parentheses, all less thans. All right, here we go. Doing a good job. Absolute maximum. So we know the words maximum, minimum from our quadratic unit. Maximum is the highest point on the roller coaster. Minimum is your lowest. But now we're going to have absolutes and relatives. So they're a little bit different. So the absolutes is the largest y value. And the absolute minimum is the smallest y value. And now to make things even more confusing, we're going to describe with the y value. So we do not describe the maximums with the x. We're going to describe with the y. So describe with the y value. Okay. And then before we actually go to our graph and look, I'm going to write a little bit of notes down here. You know all about my notes. So absolute, max, and minimum can, but does not have to be a turning point. And now we know turning point, again, from our quadratics. It's where the direction changes. So you're going uphill, you have your turning point, and then you're going downhill. Okay. Can only have one of each. So that's really important. There can only be one highest point on a graph. Okay. There can only be one lowest part of the graph. Okay. So let's work on those now. Absolute max and absolute min. Okay. So where do we see the highest point on the graph? Well, the highest y value on the graph is 7. And that coordinate is 5, 7. Okay. So this right here, we're going to write absolute max. That's an absolute max. Okay, where is the lowest part? Well, that's right here, -9. So this is going to be absolute minimum. So highest point, there can only be one of them. Lowest point, there can only be one of them. And we're going to describe with the max, with the y value. So y equals 7, or I've also seen it ask for the coordinate. Usually it's just the y equals, but they could say what is the coordinate of. If they don't say what the coordinate is, I would suggest just writing the y value. All right, and then our smallest was y equals -9, and again, there is your coordinates. Okay, so that wasn't too bad. I think the only hardest part is really positive and negative, maybe. All right, so the last two are your relatives. So this is going to be something different. Okay, it's still highest to lowest, but there's something more specific now. So when it says relative, that's your maximum turning points. Turning points, where this is your minimum turning points. Okay, and here again, you're going to describe with the y value, describe with the y value. So the difference between these is that the absolutes do not have to be a turning point, okay? This has to be a turning point. And that's what I'm going to write down here. So must be a turning point. And for these ones, you can have multiple relative max and mins. And these guys over here, these can actually be the same. So you can have a dot that's an absolute max and a relative maximum. Okay, that is okay. Here does not have to be a turning point. So for example, this was not a turning point. Okay, this one over here was not a turning point. Okay, this one was. This was not a turning point. This one was. That's okay. But when we're talking relatives, it has to be a turning point. Okay, it has to be a turning point, and we can have multiple. All right, let's try to figure this out. So I'm looking only for my turning points right now. Only looking for the turning points. Okay, my highest. So no good. This is a turning point. Okay, my highest here and here. Okay, this I cannot use. Okay, I cannot use because it is not a turning point. So what's my next highest as a turning point? Bingo, right here. Okay, so you're looking for your highest points on the graph. That would essentially be this, but because it is not a turning point, actually maybe let's write that. Why not? Cannot be a relative max, not a turning point. Okay, this one is. All right, my lowest. So you kind of like looking over here and over here. Is this a turning point? No, the direction's not changing. It's starting. This is. So here's a dot that not only is an absolute min, but it's a relative min, and that is okay, right? I said before that they can be the same exact number. Okay, I said that before, that they can be the same exact number. All right, so -4, 4, or y equals 4. Okay, so again, let me show you that. Y equals 4 was right over here. That was a turning point. That's a relative max. Okay, you can't pick this one, not a turning point. And then for the relative minimum, y equals -9 or 1, -9. Again, only give the coordinates if they ask for it. I would stick with the y values. Only give the coordinates if they ask for it. So our relative min is right there. Okay, this is not, because that is not a turning point. Okay, oh boy, that was a lot. So we're going to do one more example. It will go a little bit quicker